Welcome back to my YouTube channel. In this video, again, we're gonna see how we should solve the this integral with Feynman's technique of integration. So this integral is incredibly similar to the integral from 0 to infinity of sine x over x dx. And let's read the integral once. So it asks us from the integral from 0 to 1 of sine of ln x over ln x dx. So to make our work simpler, and you'll later see why, I'm going to multiply and divide both sides by negative x over x, and again multiply and divide the sine of ln x over ln x by a negative and divide by a negative, so I wouldn't have changed anything. Now, negative sine of ln x is actually equal to sine of negative ln x. So here, negative x over negative x, sine of negative ln x over negative ln x dx. What I'm going to do, I'm going to define u to be negative ln x. Thus, the u is negative log base e of x, and x equals e to the negative u. X equals to e to the negative u. And if I differentiate both sides, du is going to be negative 1 over x dx. If I now substitute all of them for my integral that I'm looking for, I'm going to get negative e to the u, and I'm substituting for this, and this whole thing here is going to be du, and sine u over u du. But we gotta keep in mind that we should also change the bounds. If my u is negative ln x, u when it is equal to 0 is infinity, and u is equal to 0 when it equals 1. So my bounds would be from infinity to 0 of negative e to the negative u sine u over u du. Now, I can define f of t to be the integral from infinity to 0 of negative e to the negative ut sine of u over u du. And when I find the f of 1, I actually found the integral that I was looking for. Okay, so now I'm gonna differentiate both sides, and this is gonna become a partial derivative when it moves to the integral, negative e to the negative ut sine u over u du. My f prime of t thus is the integral from infinity to 0 of u e to the negative ut sine u over u du. Now I can cancel out the u's here. So my f prime of t is going to be the integral from infinity to 0 of e to the negative ut sine u du. So I'm going to define my n to be e to the negative ut and dv to be sine u du. Thus my d would be negative cosine, negative cosine of x, so negative cosine of u. Now if I substitute back the whole thing, I'm going to get e to the negative ut times negative cosine u from infinity to 0 minus the integral from infinity to 0 negative t e to the negative ut times negative cosine u du. So the f prime of t is, this whole thing here is going to be negative 1 because e of 0 times cosine of negative cosine of 0 is negative 1, and e of negative infinity is 0, which if we multiply it by cosine of infinity is 0. So this thing here is negative 1 minus t times the integral from infinity to 0 of e to the negative ut cosine u du. So now my f prime of t, I'm gonna do another substitution. N equals e to the negative ut, dn equals negative t e to the negative ut du. My v is gonna be sine x and sine u, and dv equals cosine u du. And if I again substitute back the whole thing, it's going to be negative 1 plus t times e to the negative ut times sine u infinity to 0 minus infinity to 0 of negative t e to the negative ut sine u du. Now the whole thing here again is going to be 0 because sine of 0 is 0 and sine e of negative infinity is again 0. So it's going to be negative 1 plus t times negative. So this thing here becomes positive integral from infinity to 0 of e to the negative ut sine u du. My f prime of t thus is negative 1 plus t squared infinity to 0 e to the negative ut sine u du. So my integral that I was looking for, here, this should have been, this should have been negative here. I forgot a negative sign because here we had negative t multiplied by this integral here, so minus t multiplied by this whole thing, and yeah, it's minus t squared. Just sorry for the mistake. F prime of t is negative 1 minus t squared f prime of t. F prime of t plus t squared f prime of t equals negative 1. Thus f prime of t is negative 1 over 1 plus t squared, and f of t, if I integrate both sides, is negative arc tan of t plus c some constant of integration. And if I take the limit as t approaches infinity of both sides, infinity to 0 e to the negative infinity sine u over u du equals limit as t approaches infinity of negative arc tan of t plus c. It's going to be c minus pi over 2 equals to 0. Now c equals to pi over 2, so f of t equals negative arc tan of t minus pi over 2, plus pi over 2. We were looking for f of 1, which was integral from infinity to 0 of, from 0 to 1 of sine of ln x over ln x dx. And now if I substitute f of 1 for a function here, it's going to be negative arc tan of 1 plus pi over 2, which is negative pi over 4 minus plus pi over 2, which is 2 pi over 4 minus pi over 4, which is in fact pi over 4. My f of 1, therefore the integral from 0 to 1 of sine of ln x over ln x equals pi over 4. A very neat result that gave us the following thing, and it was quite a little bit of work, but Feynman's technique is my favorite approach in integration. And I hope you enjoyed this video. If you have any questions, please let me know in the comments. I would read every single comment of yours, and I will see you next video.